All right, ladies and gentlemen, we're going to go over this here. We've been working on this for the last few minutes. Okay, we have here, find the velocity at any given time t. What is going to be our strategy on this one here? Yeah, so what we have is x of t equals this here. So velocity of t is the same as x prime of t, which is t squared, is that right?
Yeah.
Minus 8t
I don't either. Surely it needs something, right?
plus 15.
That's what I got.
Like Nairobi.
Okay, then ask what is velocity after 6 seconds?
Oh, I didn't know that one was changed to 6.
What's velocity after 6
Oh,
seconds?
I didn't know that one was changed to 6
I
either.
thought the bottom one was changed.
Shoot, Mr. G.
So v of 6,
You tricky guy.
let's go ahead and plug that in here. So we get 6 squared minus 8 times 6 plus 15. And I'm looking at, that's going to be, what, 32 minus 48?
36.
I think it's 36.
36.
36, thank you. 36 minus 48, that's going to be negative 12, is that right?
Sounds right.
And negative 12 plus 15 equals 3. So 3, and we say what units? And we look for the meters, right? It's going to be meters per second. When is the particle at rest? And then we'll justify your answer. When is the particle at rest?
What happened to you?
Okay. T equals at T equals 3, and also T equals
Cinco.
5. And why is that? Because V prime, or V of t is equal to 0, right? And I don't know if you did the number line, and then we talked about, now we get to our friend, right, the number line. And then we got this thing right here. We have 0 equals t minus 3 times t minus 5, and that's where we get our critical numbers from. So we get 3 and 5, and then we have here is going to be v of t and x of t down below, and for less than 3 we have negative times a negative, which is
Positive.
positive,
Positive.
and then between 3 and 5,
It's negative.
negative, and greater than 5 we have positive increase, right? So when is the particle moving to the right? On which intervals?
Between, we'll start at 0, 0 and 3 and 5 and 30.
Yeah, so 0 to 3, and also 5 hasta infinidad, right? Okay, find the distance, total distance traveled by the particle during the first 6 seconds. What do we do for that?
So we do like a chart.
Chart, right?
Yeah, chart.
So x, so we have RB t, right?
Uh-huh.
T and then x of t. So what are the critical numbers we put down here?
0,
0,
3, 5, and
3, 5, 6. And we had a discussion on this yesterday, and Carson wasn't here for that discussion. Did you watch the video on that, Carson?
I watched part of it. I didn't get the rest of it.
You watched part of it? Well, anyway, what it is, is we know that at 0, at time equals 0, the velocity, velocity is positive, right? So here we go. So we're going along the line. So from 0 to 3, we cover this kind of distance, right? And then we're slowing down. So what happens at 3? Backtrack like this, right? And what happens at 5? Go forward again, up till 6 seconds, according to what's being evaluated. So that's that. So anyway, you're looking not at displacement, you're looking at distance.
So, real quick, when you're going back for a total of 5, or like, till it reaches 5? So-
Yeah, what it is, this is time. So for the first 3 seconds,
So that
going that
takes us
direction,
back forward.
and after 3 seconds, went back for 2 seconds, and after 5 seconds,
Go back one more.
go back that way.
Yes.
And the distance, so it's not, we'll see what the distance is, and we'll be able to explain what that is in better detail. But you're talking about total distance, because you're not looking at the difference between this number here and this number here. You have to find all these absolute value, because this going backwards here, that's going to be a positive value too. So it's whole distance traveled. So at 0, what is x of t at 0?
5.
5. And then at 3, then we have to just plug in for 3, right? So 1/3. Did you figure that out? So 1/3 times 3 cubed minus 4 times 3 squared plus 15 times 3 plus 5. So what is this going to be? 20, that's 27 divided, that's going to be 9 minus 4 times 9. What's 9 minus, that's 9 minus 36, it's going to be
I think it's 23 total.
negative 27. And negative 27 plus 45, because that's 45, right? Negative 27 plus 45 is going to be, is that 18? And 18 plus 5 equals 23. And one thing you're going to do is you're going to check and make sure that we know that velocity was positive between 0 and 3. And so what do we have to have for that to occur? We have to have that be a positive thing. And then at 5, we've put in 1/3 times 5 cubed minus 4 times 5 squared plus 15 times 5 plus 5. So that's going to be 5 cubed. Is that going to be 125? Is that right?
Yes.
So we're going to get 125 over 3. And then we have minus 4 times 5 squared. That's going to be minus 100. Is that right? And then 15 times 5, what is that going to be? 75 plus 75 plus 5. So negative 100 plus 75, that's going to be minus 20, right? So you got 125/3, and 20 is going to be 60/3, right? So that's not going to be 65/3. Man, I don't know if that's right. Let's check this out. 65/3. What is 65/3 going to be approximately? 21, like 21.6 something, right? So yeah, so that is a negative distance. And then at 6, we have 1/3 times Now here we get into 6, that's almost like, hey, we need a calculator for this. 4 times 6 squared plus 15 times 6 plus 5. So we got 6 cubed, that's gonna be what, 216?
C,
And 216 divided by 3 is,
72.
so we get 72 minus 4 times 36, that's gonna be, is that 144? And 15 times 6, that's, let me see, 90, right? Is that right? 15 times 6 is 90?
Yes.
Plus 90 plus
C,
5.
Senor.
So we got, that's negative 72. Negative 72 plus 90 is 18. 18 plus 5 is 23.
Back to 23.
So you can see that we went down a very little distance here. We got up to the same place and went back. And this distance here, let's see, that's gonna be 69 thirds, right? So 69 thirds minus,
4/3.
so 4 thirds here, and we got another 4 thirds coming back the other way, right?
That's 8/3.
So 8 thirds. So the total distance traveled was 18 plus 8 thirds. And we could make this into thirds also, right?
54 thirds.
Yeah, 54 thirds.
62 over 3.
So 62 thirds would be total. Is our total distance.
Meters.
Okay, next, find the acceleration of the particle at any time and at t equals 3 seconds. How do we find that?
Find the derivative of.
If t equals v prime of t equals
X double prime
2x minus 8, right?
T. Yeah.
Or 2t minus 8, excuse me. And that's the acceleration, and at time t equals 3 seconds.
I don't know.
Okay, v prime of 3 is equal to 2 times 3 minus 8, which is negative 2 meters per second squared. And now we're asked the question, is the particle speeding up or slowing down at t equals 5 seconds? Justify your answer.
Oh, Gordon. Oh,
Okay, we're speeding up, we look at the velocity and acceleration. Well, for acceleration, if we plug in 5, we're going to get 2 times 5 minus 8. So we'll get 2, right? I mean, yeah, 2 times 5 minus, so that'll be, so acceleration is positive, right? What about velocity at t equals 5 seconds? Velocity equals 0. So are we speeding up or slowing down?
Speeding up.
Nope,
No, we're slowing down.
we are neither.
Neither.
Why is that?
because velocity is.
Because velocity is at 0. So it's right here, it's doing that back and forth walking I was doing here. First 3 seconds like this. Next 2 seconds, we went back just a little bit. And then right at t equals 5 seconds, what happened there?
It's-
Motionless.
it's-
We're motionless at that instant before we go forward again. So then, we have neither slowing up or speeding down.
I was confused because there was one of the critical numbers between and wasn't doing anything.
Okay, well, to me, this thing here, the only part that was hard, if you want to call it that, was the detail on the total distance with the fractions. Right?
Yeah, that was the hardest part.
Stinky fraction.
And do you find out in this course, a lot of what's hard is almost that, like the details of what it is? Yeah.